So hello, everyone. Welcome to the second Go compiler and runtime office hours. In case you weren't here for the first one, I'm Austin Clements. I'm the tech lead of the compiler and runtime. And we've got a whole bunch of people from the compiler and runtime here at Google on the call, and a bunch of people from the community. And yeah, there is no particular agenda for this. Just use the raise hand feature, and we'll go through people and ask questions, and we'll just talk about what's going on and answer questions that people have, and sort of get to know each other a little too. So who wants to go first? Daniel.
Hello. I missed the first call. I had plans, apologies, but I noticed that you've all been working on binary sizes a bit lately, and I was looking at the dead code pass in the linker recently, and I sort of understand why it's an all or nothing with whether or not reflection is detected to be used with method by name and stuff like that. But if I have a large program, a main package with a tree of dependencies, is there an easy way to tell whether dead code is being disabled or not, and why? Like what dependencies are causing that, for example? Like, for example, I can go mod vendor and grep for reflection, but that's very hacky, right?
I imagine the linker could mention what function triggered the behavior, but I don't know that any more fine-grained than that, or if that's what you had in mind. Like the linker has debug flags for explaining like different dead code stuff. I could see a linker flag for this function called a reflection method, so that's why we decided to be more conservative.
Yeah, honestly, if I was pointed at a package, that would already be a great start. So function is even better.
Oh, that's interesting. So you're just looking for like, why is dead code seeing reflection?
Yeah.
You might be able to actually get that now. It would certainly be easy to instrument dead code to just print that out, but there are various flags to the linker that ask it to dump sort of its understanding of the reachability graph. And so it'd probably be relatively easy to sort of just see what edges in there are to reflection.
Yeah, there might be some form of Go tool list, Go build list, or whatever might also tell you like how reflection gets imported.
I'm not sure that's enough, because importing the reflect package alone doesn't disable dead code, right? It's only if I use things like method by name.
Just to be
Right, that
clear,
would tell you what
it's not-
packages import it, and then you'd have to grep those packages.
It's not a complete disabling of dead code too. It's just it's less aggressive about methods. So if something is not a method, it will definitely still be dead coded.
Yeah. And anything more aggressive than that is tricky, because you could be constructing up arbitrary strings.
We can know that the argument to method by name is a constant string and be more aggressive
Yeah.
in that situation.
The moment
it seems like the likely case.
I guess so. The moment you have a single non-constant string in your entire program, though, again, you fall off a cliff. But
That would be no worse than today, though.
true, yeah.
It would be interesting to know if method by name was usually with a constant string. Offhand, I have no idea.
We are a search company.
The angle that I was thinking here is if I have a large tree of dependencies, I want to know which ones are sort of abusing reflection a little bit by using, for example, method by name with variable strings. Because if they are, I might want to drop the dependency or patch it so that it doesn't get in the way, for example.
Yeah, that makes sense. I think you actually can just ask the linker. I think there's a flag to the linker right now that'll basically dump out the whole reachability graph. And you might just be able to grep that, honestly. I'd give it a shot, but yeah, if that doesn't work, certainly add a flag into dead code. Just some debugging flag. Because the linker doesn't have the handy like extensible -d debugging flags that the compiler does. -c. -c is dump call graph. I think that's what you want.
Templates
Templates?
that use reflection.
Oh, well, yes. Templates definitely use reflection. With non-constant strings.
Mm-hmm.
Okay. Shall we move on to the next question? Reese.
Hello, I'm Reese. I'm from Twitch. I am interested about support for big machines. I'm not totally sure what a big machine is, but sometimes we have GOMAX procs of like 36 or 48 or 96, and that seems big from the runtime's perspective. Couple of the problems that I've run into are that there are lots of Ps, which means lots of local run queues. And so finding work is slow. And the latency that it takes between when a Go routine becomes runnable and when it starts running appears longer when we run on bigger machines. And some of these Ps are idle for like hundreds of milliseconds at a time, but they still get checked every time. And the other like crack that I'm seeing in Go's support for big machines is things like lock contention on channels. I have an issue open for a channel that's supposed to be a concurrency limiter, but it turns out that every P in the program gets stuck waiting for this for the lock on that one channel. And
Sure
so
sounds like a concurrency limiter to me.
Yeah, but it's supposed to prevent one request from dominating the entire machine, and like it's great.
Not like that.
Yeah. So part of what I want to know is like, are we using unusually large machines, or is there something else that's strange about what we're doing? And if anyone has thoughts on roadmap here.
I assume Jacob has a separate question, so I'll jump in.
Here, just a logistic thing. Jacob, I added your name next in the notes. So if you want to take your hand down, I think we can track it that way. Since we don't have two hand cues. Sadly.
Yes, thank you.
I'll talk a little bit about GOMAX procs. I've investigated high GOMAX procs as well a little bit, a year or so ago maybe, and definitely. I mean, it's clear there's just a lot of things in the runtime that are linear with GOMAX procs. Like we loop over every P, and so you're going to spend more time. For instance, IMs trying to go to sleep have to look at every P to try to steal work and so on. And I particularly, if I remember the benchmarks I saw, things would get particularly bad like noticeably bad just in terms of like increased CPU usage above like 256 Ps, which is higher than you said. But definitely like measurable at like 96 and stuff as well. And a year or two ago, I did do some work to improve this. For instance, there's what's it called? Like there's a couple masks that basically say like which Ps might possibly have timers, which Ps might possibly have work, and we'll skip looking at Ps that aren't in that mask, which speed things up a little bit. Long term, a lot of us have brainstormed and talked about, we really love to get rid of Ps or get rid of GoMax procs in general and like have some sort of more scalable system, but we don't really have a concrete design of what that looks like. It's more just aspirational at this point, I'll say. And yeah, in terms of what's too big, I mean, I would certainly say anyone running GoMax Procs 96 is definitely probably on the upper end of what people normally run. I don't have actual statistics, but we do want to improve that. You know, I mean, machines are only getting more cores, so it becomes a more pressing problem every year, I'd say. Michael, you had something to add, I assume.
Yeah. I'm honestly surprised you're not seeing issues with other locks in the runtime, because the general global locks we use are not sort of quote unquote scalable locks, so they do collapse. A while back we did some work on the allocator to make sure that that didn't happen, and at least flattens out, but it flattens out at like 10 cores. So like, you know, that's definitely, you're not like gaining much in terms of like allocator throughput, for instance, by having more cores. We also are aware of other fun like cache coherency scalability failures. There's probably a lot of like small constant costs that you're maybe not even seeing necessarily in you might not even see in traces and stuff, but I'm sure all of this adds up. Yeah, we do benchmarking at these core counts. It's just sort of like it's a lot of work to knock down all of these different things. One thing we were thinking of though on the scalable lock thing is a while ago we thought, should the default runtime lock just be scalable, so we at least don't have collapsing locks, right? That might help with channels too, because channels just use those locks. I mean, it's, you know, not great. It'd be better to have a better channel implementation, but
Austin?
I happen to have a soapbox here, partly because I wrote a PhD thesis on all this stuff. So a bit of background for people who may not know this terminology. There's a concept of a scalable lock and a non-scalable lock. I hate these names. I call them collapsing locks and non-collapsing locks. So a sort of your typical lock, which is called a non-scalable lock, and I call a collapsing lock. As you put more pressure on it, it sort of it starts getting worse once you go past a certain point. Like the overhead of it doesn't cap out at some constant overhead. Most locks fall into this category because they are the lowest cost when they are not contended. But as they become more contended, they actually harm your performance more than even just the serialization that they're already doing. And there's another category of lock design called a quote unquote scalable lock, which I call a non-collapsing lock, because a lock is by definition not a scalable thing. That the idea is that sort of as you put more and more contention on it, you're going to get the serialization from the lock, but it doesn't get worse. It doesn't make things worse once you get past a certain point of contention beyond just the inherent serialization of it. So sort of the scalability, the performance curve flattens out rather than going back down. But we don't use those by default because they're higher cost in the non-contended case. There are still research papers being written on this stuff. So like we have not solved this as a computer science community, but that's the idea behind scalable and non-scalable locks. And hence why we've been thinking like maybe we should just make the default runtime lock be a scalable lock and sort of bite the cost for the non-contented case. Or, you know, we have two types of locks in the runtime, but I think we would have a very hard time necessarily choosing which one to use in the right case.
Right. Michael K., I opened a bug a month or two ago that you've seen on lock contention on mheap with gomax procs of 16. So it shows up sometimes. This is the scavenger was being a little too aggressive.
Or I have something quick to say about that, which is
Okay.
just that was the scavenger running wild. I sent
Okay.
I sent you a patch if you want to try it. Yeah, we usually don't see contention that hard on mheap anymore. It can happen in some specific cases, but typically not really. There's still some overhead, but it's usually not exploding. I think based on the execution trace you shared with that, it's actually a specific sort of like not quite pacer, but memory limit pacer thing. So
Right. Okay. I didn't try the patch that you sent because the team went forward with building a pacer in user space, and it's working great.
oh nice. Okay.
Yeah.
Well, I'd love to hear more about what that looks like. We should let Keith go, but sorry.
Yeah, I was just going to say that in regards particularly to channels, we've had a couple designs in the past of various levels of non-blocking channels that don't require you to grab a lock every time you NQ or DQ something. I'm not sure those patches are still in a point where you could apply them and try them, but maybe they are, in which case it would be interesting to know whether they help.
Is that for the case that there are either items or space available that the channel is partly full? Because the problem that I'm seeing in this particular app is that the channel is completely full or completely empty. It's completely contended, and so there are a lot of go routines waiting for the first spot or for the first item, and they get spread out over all of the P's because there are like 1,000 of them, and they consume all of the P's. Every P needs this one lock, and it can't run any other go routines that don't need that lock because it doesn't know.
Right. I think it would help to the extent if you're trying to do a parallelization limiter. As long as the limit you're trying to set is more than one, I think some sort of non-blocking channel would help, because at least, you know, if you're trying to limit it to 2, I think at least half of those grabs would be satisfiable without putting the P to sleep. I think when you need to put the P to sleep, you sort of have to grab a lock. But if you're just trying to grab something out of the queue or put something in the queue, it's not totally full or not totally empty, I think it would still help. But it's a good question.
So I'm curious what the results of those experiments with the non-blocking channels were and why they didn't make it in.
The first round of that didn't make it in because we just weren't all that confident that the code was correct. It was very, very scary as far as what it was doing with write barriers and all kinds of other stuff. And so we never went forward with it.
I can add even more color to that. At least the very first attempt at this, which Dmitry Vyukov did, sort of simultaneously did the non-blocking thing and did a major refactor of how the sort of channel code was structured. And from my understanding, Russ was basically like, we can't do these both simultaneously. Do the refactor first, and then make it non-blocking. And then we did the refactor. Dmitry did the refactoring, and then never quite got back to step 2. I mean, there is sort of it would be very interesting to try a non-collapsing lock for channels specifically. The other half of my soapbox about all of this is that there is non-blocking algorithms are not inherently better than lock-based algorithms. In fact, lock-based algorithms are often better than non-blocking algorithms because they're much simpler. What it comes down to is contention. And you can have contention in either. And using sort of very fine-grained locking, so you limit the contention that's inherent in the use of an API, is going to get you about the same results as if you break your brain over a non-blocking algorithm to get the same sort of reduced contention out of that.
Yep, that's totally fair.
This has been my TED Talk. Thank you for attending.
What does it mean to get rid of GoMax procs to get rid of Ps?
Oh, Michael, you go ahead.
Oh, okay. I mean, the basic idea is that you'd have a setting like GoMax procs equals infinity, and the runtime just finds the natural level of parallelism that it has available to it. So it doesn't need to be told how many processors it has available. It just tries to schedule things, and as long as things are running, then it assumes it has that CPU time. But once it's scheduling things and they're not actually running, then it stops scheduling those things. So, like, my straw man proposal for something like this is to schedule an idle priority thread. Like, I don't know if you can do this on all operating systems, and then that thread will bring up new Ps while it keeps getting scheduled. And then you have to have some mechanism for like cutting the number of Ps if you're finding that you're running things but things aren't actually running. I didn't get that far. It's not even a straw man, it's half of a straw man. But
and so Ps are kind of ephemeral, and when their local run queue empties, then they kind of cease to exist.
Yeah, basically that's basically the idea, and it might end up looking like we remove the concept of Ps entirely. I just framed it in terms of Ps because it's easier for me to think of it that way. I mean, you still have this concept of a processor resource, but you don't necessarily need to represent it anymore, right? You just kind of stop scheduling the thing stop scheduling a thread once or like you put a thread to sleep once its queue is empty or something like
that. The other problem with Ps is that right now they really deeply couple a lot of resources that are necessary to execute Go code with the sort of what is effectively a semaphore of GoMax procs. And so we've also talked about like it might be possible to sort of decouple those concepts where GoMax procs is just a semaphore, and maybe that's set to infinity, maybe it's not. And separately, you have a pool of resources for executing Go code, and that pool can grow and shrink much more easily than the sort of when they're coupled.
Okay. Thank you all.
Should we go on to Jacob?
I yield, but I'm happy to come back after Jacob or after whoever's after Jacob to talk about user space pacer.
Yeah, so hello everyone. I'm here with a friend of mine, Ori, and we're both representatives from the Ninefront project, so Plan 9, and we are trying to make stuff easier on the Go team for getting and maintaining the Plan 9 runtimes or the versions of it. We thought it'd be nice to kind of pop in here and give a face and to kind of figure out what kind of our actionable next steps would be to help kind of, keep that that version of the compiler in runtime alive.
Basically what he said. Although I do object to representatives.
About as close as 9front has, I think.
Yeah, just a bunch of nerds. So one thing, obviously, we'll need to get runners up. I think this is the wrong forum to really discuss the logistics of that. But if there are any things that are kind of cause some pains in the ass, or people pointers to people that we should talk to, I think that's probably worth bringing up. If not, well, I'm happy to move on to Rus's next user space base or two.
Yeah, it's a good question. Let's see. I don't sort of have this at the top of my brain. I don't know. Do other people? I mean, I know that sort of. This is so. Sorry, are you asking specifically about Plan 9 ARM 64? Right, that's what was recently proposed.
That's kind of
that was recently proposed, but it also, I think, in the thread there were kind of a bunch of things that people were complaining about, like Go mode SSH needing a draw term binary in the path, which most people don't have.
Yes.
Or
it seemed that when Philip proposed the ARM64, there was kind of a lot of stuff that we needed some spring cleaning before. I think it seemingly seemed like there needed to be some spring cleaning before there was another architecture added.
Yeah, I don't follow all this super closely, but I'll give my perspective, which is I think there's a couple of there's two sort of big issues with the existing Plan 9 port stuff that I can think of. One of which I think you already mentioned, which is the builders, and just having either more builders or more reliable builders. I know at one point I was trying to debug something using a builder, got a Go mote, and I waited like 8 hours for the Go mote to appear, and then after it appeared, I logged in, and 30 seconds later it crashed, and I had to go to the back of the queue.
So
that was not great.
So with all honesty, sorry, go ahead and finish.
Oh, I was just gonna say, I think I've seen proposed, I don't know how feasible this is, I've seen proposed getting Plan 9 builders running on GCE or AWS or like some cloud where they're more
GCE for GCE for AMD 64 and 386 is easy. I've gotten that working. I just don't have keys for it, and I don't know how to test it out.
Yeah.
For ARM64, it's a little bit more of a pain because I believe that I was looking at GCE. I believe that's running on Ampere CPUs. Nobody's ported that there yet. I don't think it would be a giant task to get it running there, as long as there is easy access to a serial console and so on. But AMD 64 and so on builders, it's not a problem.
I also want to say, as far as I know, all of the current builders that are running are original Bell Labs Plan 9, which hasn't been updated in 10 plus years, more or less. We, 9front, we're actively updating, fixing performance issues, and porting to newer hardware. And so I think to me, it sounds like perhaps it's time that we try to set up some 9front runners running some more up-to-date code from what we have, both to help, I guess, help us to make sure that we're not making breaking changes, but also to hopefully kind of alleviate some of those pain points so it doesn't take 8 hours to connect to a builder as well. That would be something we hopefully would be able to make not be the case.
Yeah, I think generally, like, I don't know if folks have concerns about like which version of Plan 9 is running or not. I think generally as a secondary port, like whoever the secondary port maintainers are, which yes, includes you all. It's up to you all to decide like which versions of the OS are most important to test / support, and whichever is the best for that is probably what you should use. And yeah, the other issue I see with Plan 9 that comes up a lot is that the builds are just very flaky. Right? There's a lot of failing tests, and I think everyone would be happier if either they're fixed or it's figured out that, like, there are known issues and we're going to skip flaky tests and mark them as skipped on Plan 9. Just because I think for anyone who's a maintainer, like you can't look at the dashboard and tell if new commits are causing problems if everything's just failing across the board. It's very difficult. Yeah, that's my general take.
Okay.
No, and I think that's something, I think, Ori, just from anecdotally, I don't think I've had too much inconsistent tests failing lately when I've tried, although, again, that's only anecdotally.
I've
Or at least
I've seen a couple of things that were flaky that we'll need to get to the bottom of. I don't remember which one. It was something weird. For a while, the Plan 9 tests were passing a lot more than they should have because I sent a patch for this, but there was a breakage that made all unsuccessful exits of processes look successful.
Oh, good.
Yeah. Oops. So that one's fixed now, but I think that might have been one of the bits of flakiness. Unless it actually crashed, it was a success. But once I got that, most of the stuff was passing. I think the last time I looked, there were like 2 or 3 that were failing and a couple that were flaky that I haven't gotten to, but we'll get there.
I'll go ahead. Yeah, I think sort of related to the builder issue, this is much less of a problem now that we've adopted the new port policy, but certainly before the new port policy, like anytime that I had to debug something on Plan 9, just from sort of an infrastructure perspective, I was always very sad. Like if I had made a runtime change and it wasn't working on Plan 9, what do I do? I think that's more your problem now that we've adopted the secondary port policy.
Yeah,
like
and
we try to keep it running, but if we just can't figure it out, we're just like, oh well.
Yeah, and I think that is absolutely the right thing to do. Plan 9's our problem, not yours, or at least that's the way it should be.
And the other sort of more general thing we've run into with Plan 9 is, I'm not sure this has been such a problem for recent changes, but
it's weird.
In the past, like we've made changes to the runtime where like it makes assumptions about the operating system that work everywhere except for Plan 9. We still the memory manager, like the Go memory manager on Plan 9, the sort of lowest level of it that actually gets you memory from the operating system, is very weird compared to all the other architectures. Because like everywhere else we can sort of ask for these like large aligned mappings and sort of do VM tricks that at least as far as I know are still not possible on Plan 9.
Yeah, so Plan 9 Plan 9 just uses sbreak.
Yeah.
But is the problem the size of the mapping or the?
It's not the size of it. It's that we're actually trying to sort of manipulate page tables in interesting ways. So like for example, where I remember really hitting this, and again this was many years ago, and we've sort of worked around it. Was that the runtime like has some internal memory growth stuff that it does for stuff that's not on the heap using persistent alloc. That's sort of fine with sbreak. It doesn't really care. But separate from that, the heap itself is managed in usually these 64 megabyte chunks that are 64 megabyte aligned. And we play like careful mapping tricks with that to sort of get these big chunks. And when all you have is sbreak, I suspect this is still true, but I guess people haven't been complaining about it. When you like do some persistent allocs, and then you need another heap arena that's 64 megabyte, 64 byte aligned, we wind up just like throwing out a huge amount of memory because we just have to like align the sbreak up to 64 megabytes in order to get our chunk. And then we do like a few more persistent allocs, and then we need another heap chunk. So sort of the memory manager is built around modern virtual memory sort of structures that Plan 9 just doesn't expose to us.
Yeah. And it makes a lot of things really nice in Plan 9 because you
Yeah,
only have
sure.
storage, but it's, yeah, I understand why it's a pain. Okay, that makes sense. Okay.
Yeah, I don't remember if we have any more recent examples of that. That was one of the biggest thorns in my side
Yeah.
many years ago when I was doing this arena stuff and
Yeah, makes
sort
sense.
of worked around it.
Honestly don't remember how, by what miracle the page allocator works on Plan 9.
Yeah, that's true because the page allocator also tries to do
think
big
it-
virtual mappings.
I think it might assume a 32-bit address space or something crazy like that, which is not great. Yeah.
Hmm.
Couldn't find that.
Okay. I think that's pretty good for me. Moody, do you have anything else or?
No, I didn't have anything else to add particularly here.
Cool.
No, it apparently doesn't. I guess it is just fine.
Okay. I mean, this might be another thing where it's like actually just throwing out gobs of memory and nobody seems to mind.
I mean, that's what demand paging's for.
Yeah. Plan 9 at least doesn't seem to complain about using lots of virtual memory, unlike some other operating systems that shall remain nameless.
Yeah.
Oh yeah, you mean like OpenBSD?
Every operating system has its incredibly frustrating quirks.
Yeah, I guess we just make these enormous S breaks on AMD64 and it just doesn't care. That's nice, actually. I'm glad that it doesn't care.
Yeah, I mean, if it cared, that would be something that I think we'd be willing to fix in Plan 9.
Sure, yeah.
The other funny thing here is that I was doing this all before we had WebAssembly support, and WebAssembly actually uses the same virtual memory management mechanism as Plan 9 because WebAssembly also, in effect, only has SBreak.
Yeah,
which I
man,
cannot comprehend, but that's where we are.
yeah. So funny story. A long time ago, I posted the complaint about WebAssembly not supporting arbitrary go-tos, and I'm pretty sure that that one got a lot of comments from the Go team. It's still generating comments about 7, 8 years later.
I guess the only other thing I know you just asked earlier, so I didn't have anything else. I guess, if there's any sort of way that, if there's, issues with the Plan 9 port or ways, if there's, kind of ways to get in touch with us better or ways that we can kind of get more subscribe to these kind of things when things kind of, so we know when things are broken so we can help try to fix them, I think is part of it too.
Are you in the GitHub group for Plan 9 maintainers? Because we do consistently CC. Yeah, Matthew just
Okay. Well, this I don't believe so because I get a 404 with that.
Huh. Yeah, that is interesting.
Yeah, I mean, we're both kind of, there's kind of the schism in the Plan 9 community, 3 people on this side, 2 people on that side.
Yeah.
But
I mean, we don't necessarily have to recreate that schism.
No, I don't. I'm just saying that
Plan 9
we're just kind of, it's been the 9 legacy folks that have been doing most of the Go maintenance work so far, and us sending sporadic patches rather than us being the face of the Go support, I guess. So I think it's not surprising we're not in that. How do we get added?
That's a good question. I'm not actually sure.
I mean, the if you file an issue, we will see it. It will get triaged, and someone will post about it on a chat, and then it will happen.
Okay,
Something,
good.
yeah, like it's
I think the
Okay.
question was how they get added to the Plan 9 port maintainers group, right?
yeah, that's what I mean, because like I don't like only people who are administrators of the group are allowed to add people to the group, and that I don't think includes us because I'm on the page right now and I can only request to join. So
Okay. So basically, file an issue and ask for it.
yeah, and we'll figure it out. I guess we just don't have an official process for this yet or something.
No worries.
Maybe I'm just misremembering.
If we file an issue and
It
there's an
makes it
official
way better.
process, I'm sure we'll find out.
If it makes you feel any better, I don't even see a way to join. So
All right. So now back to your regularly scheduled stuff that affects most people. I think the user space pacing, unless someone else had questions.
Unless someone else. I don't know that it affects most people.
Break my heart, Reese.
Fair enough.
Okay. So to start off with, there's a particular app that I support that serves latency sensitive requests. Typical response time is like 10 or 20 milliseconds, somewhere around there. And in order to serve a request, it needs a bunch of data in memory, and it periodically reloads this data. And so it runs with the live heap is like 9 gigabytes. And occasionally it reloads the memory and allocates like a gigabyte at a time. And that comes as a surprise to the pacer, which is used to serving these low latency requests, which come in on a regular basis. So that causes the pacer to run a garbage collection cycle with an expensive assist load, and because like it suddenly came up short by 1 gigabyte of memory, and it needs to cover that quickly, and that slows down all go routines that allocate, which is like this one refresh go routine and like several hundred requests related go routines. And so the requests related go routines all get slowed down by like tens of milliseconds. The entire program is busy, and so even if a go routine isn't doing assist work itself, it can't get a processor because all the processors are busy doing assist work. So that is that's the explanation for this service's tail latency. And the team didn't want to give timeouts for their customers, and so they scaled the cluster out really big, so that they wouldn't have more than like 1% of requests timing out. But that costs money, and so there's interest in scaling this cluster down. So execution traces have been great for that. We found the source of tail latency. We deleted it by runtime.gc calls, and scaled the cluster down to 1/5 of its original size, which is like amazing. But getting the runtime.gc calls in just the right place has been tricky, because the refresh loop takes like a minute to run. And so I was confused for a long time as to like why like we did a GC, we say GC and then like do the refresh, and that call the refresh takes a minute, and there are several GC cycles in the meantime, and so we weren't getting them in just the right places. And so instead of finding those right places and keeping them up to date, we built what I don't know what to call it other than user space pacer, that keeps track of how big the heap is, and tries to figure out when the runtime is going to start the collection cycle, and then tries to request a cycle to start sometime ahead of that. and there's now no assist load, and we spend like a bit more CPU time doing garbage collection, but that means that we're able to make use of the rest of the CPU time in an interactive way. Michael, does that sound? Are you any surprises there?
No, I mean, we've talked through various channels. Yeah, we've discussed a lot of this. So what is the mechanism you use like finalizers to sort of pseudo schedule against GC cycles in order to make decisions, or do you just have something running in the background like spinning and making decisions, or
Yeah.
what does it look like? Okay.
It's two Go routines. One of them does the runtime.gc call on demand. The other runs every 100 milliseconds to get metrics that seem the most relevant for this. And then it triggers the other Go routine, but it's able to keep running while the GC is in progress, so that we get the data for everything that's going on.
Right.
It's been a little hard to like get the numbers that we need out of the runtime metrics package.
Okay.
Like we can tell when the GC cycle is done. The number of GCs, the counter of number of GCs increments, but like the sweep work hasn't happened, and so the amount of heap memory is still going down. And so we like keep track of the live heap, and like if it's still going down, then we keep recalculating our trigger point, and if it starts going up, then we say, okay, well, like we've reached the minimum, and that's probably the low water mark.
Is there an issue to add heap marked stats?
Yeah, heap marked helps, but it doesn't. Yeah, so we're gonna have probably in the next release, thanks to other contributors, heap marked. Or maybe that was you. I actually don't remember. But
Felix
basically
from Datadog.
It was Felix. Okay, so the actual sort of like count that Go uses to put into Go GC, right? Along with all the other metrics that go into Go GC, so you can sort of get a better idea of how far along in the cycle you are. But I think with yeah, so you don't have to do this sort of like weird accounting with sweep and stuff like that. You'll be able to know exactly how far along you are. Yeah. We're adding it for other reasons, not for helping users build a user space pacer, but it is useful for that. So that might make things a little bit simpler for you. In general, I'm sort of wondering about this, like, I don't know, it probably is too specific and too implementation specific to have an API to say, like, give the pacer a hint that like something is going to happen soon. Like, you don't even need to necessarily know exactly when, but you just know, like, in the next second or like minute of execution, something is going to happen. But even that is not really possible.
Yeah, even if it was, it sounds like a great way to give people a way to shoot themselves in the foot.
I know, but like, I'd like to get away. I'm not trying to discourage this user space pacer experiment, because I honestly love where it's going and I love what you're learning from it. My takeaway though is it like the pacer can't predict the future, right? But to some degree, you have information that you want to give this information to the GC, right?
Mm-hmm.
About like what it is you want, something about your application. Like maybe you don't know the exact trigger point, or you don't know, right? Because I know you've said like where to put the runtime that GC calls is kind of difficult to identify, right? But like even just like a broader hint to tell the pacer that like, okay, I'm gonna act conservatively. I'm gonna assume that the next few GC cycles, like I'm gonna purposely give my hedge a little bit so that it reduces assists. at the cost of a few extra GC cycles, like spending time on a few extra GC cycles. I don't know. Maybe just, reading runtime metrics and calling runtime.gc in a loop is the best way to achieve this. It just feels like it's not.
But
I mean, that's a pretty
Broadly
big hint to
speaking.
the garbage collector.
What?
Calling runtime.gc is a pretty big hint to the garbage collector.
It is a pretty big hint. That is true. Yeah, that is fair. I'm not trying to say what you're doing is wrong. I'm really not trying to ascribe any kind of judgment to it. Like, if it works for you, please continue to do it. Right.
Right. So we
Please.
we have two GC knobs now. Like, why not a third? Why not a 10th? Why not a 100th? I know
It
why.
took us 10 years
Yep.
to add the second GC knob, and maybe in another 10 years we'll add another.
Totally agree. Totally agree. But we now have two ways to tell the runtime, don't worry about memory so much. Like, please like relax. It's okay if you use 100% extra memory, 200% extra memory, like 10 gigabytes. We have ways of telling the GC to kind of relax and not worry about it in that way. But the pacer always like goes right up to that brink.
Yes. We are completely on the same page here, because someone from CockroachDB also filed an issue where basically, because the pacer is constantly pacing on the edge, literally just noise, just random statistical noise is causing them to assist like quite a lot. They just happen to be running on a noisy system, and some of their inputs to the pacer end up noisy. Like, they use wildly different amounts of stack over time, for example.
Sure.
Which introduces a lot of noise into the pacer's calculation. So if the pacer were just hedging just a little bit, I feel like a lot of these problems would be at the very least reduced at a baseline level. So what I've been looking at for the CockroachDB bug is to basically change the sort of like pacer smoothing algorithm for what it assumes allocation rate is to actually be a maximum. And I think it is going to hurt some average case performance, but it really does help a lot in these tail cases. It can be a little bit smarter than that, but that also, before Go 120, the smoothing function was honestly kind of wild, and I think at this point a mistake. And I've expressed this to you, right? So it might be a little bit better in Go 120. But I think also the CL I sent you for the scavenger thing is also operating in that same sense, where it hedges a little bit of the heap limit of the heap goal in order to avoid having the scavenger kick in, at the cost of a few additional GC cycles. But if you're using set memory limit, you still get the order of magnitude improvements. You maybe lose a little bit of the improvements, but what you don't get is this pathologically bad behavior because you're not pacing on the edge. And I think that's where the pacer has to go next, is like sort of intelligently hedging against all of these different things that it can't possibly predict, right? Because yeah, you're totally right. It's pacing on the edge. And sorry if I interrupted you or cut you off or something. I don't know if you had another thought.
The other number that would be useful that we don't have, we have the goal, but the runtime's heap goal is for when the sweep ends, and we don't have a way to just ask the pacer, like, when are you going to start the mark phase?
Oh, yeah. So yes, the heap goal is for when the mark phase ends, and we don't expose the trigger. It would be trivial to expose the trigger. In general, I've been reluctant to expose too many of these internals, just because like it does make it easier to build user space pacers, but maybe that's just what we need right now to learn more and move forward. Like, the trigger 10 years from now might not be useful, but at least we do have a path in runtime metrics to get rid of it. So I'm sort of warming up to the idea of exporting more of these metrics, because they're also just useful when we're debugging.
Yeah, I mean, the sort of exact meaning of the trigger does tend to change from version to version. Like if you actually look at the there's a function whose name is eluding me right now in the runtime that's like, should I start a GC right now? And I return the bool.
Yeah.
And like the trigger is in there, but it's not a simple like, is the heap size over the trigger?
It used to be.
It used to be, but it's grown more complex. It's not like a super complex function, but it's more complex than just is the heap over the trigger.
But you can at least sample this number, right? And
Yeah.
it's not nothing. The number doesn't move that much.
Yeah.
But yeah, ever since the memory limit, that number is now computed completely dynamically. So there are numbers that go into it that we can also expose, and like, you know, at some point your mileage may vary. Like if you want to encode what the actual trigger calculation is in your user space pacer, just to like back, you know, and then the Go version changes and you have to update it. I like that, you know, that's probably the best we can do, but we can at least expose everything that goes into it. It's probably not a bad idea.
Yeah, I've only seen one app so far that like really needed it, and so I will keep my eye out for other apps that appear to need it within the variety that I'm able to see, and like maybe it's just a super uncommon thing, and it's pretty well solved. Thanks for your help.
No, yeah, of course. I don't think it's just you. We like, as soon as 119 went out, like I feel like I reached out to a bunch of people and they came back to me with like, pacing on the edge isn't working, right? And so I think we have to fix that.
Okay.
Yeah.
Well, speaking of being right at the edge, we are at the top of the hour. So thank you, everyone. And I will work on scheduling another one of these for roughly a month from now.
Yeah, thanks for taking the time. I will probably see you at the next one.
All right.
Bye.
Talk to you all later.